Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. This is part 3 of my 3-part series with Dr. Fred Alan Wolf on time, space, and consciousness. Fred, who is also known as Dr. Quantum, is the author of more than a dozen books on physics and consciousness, including The Eagle's Quest, Taking the Quantum Leap, for which he won the National Book Award, The Spiritual Universe, The Dreaming Universe, Mind into Matter, Matter into Feeling, The Yoga of Time Travel, and Time Loops and Space Twists, How God Created the Universe. Welcome, Fred.
Thank you, Jeffrey. It's a pleasure to be here again.
It's such a pleasure to be with you. I have to say, in decades of doing interviews, the ones we have done always leave me both feeling very high and feeling highly informed.
Well, you do the same for me, Jeffrey. You're a wonderful person to have acting as the interviewer.
And it's so great to be with you again after all these decades. Well, in the last of our interviews, we were talking about time travel and how many physicists are looking at the implications of the multiple worlds theory when it comes to time travel.
That's exactly right. And one of the reasons that thought has occurred is simply because people are taking it very seriously, that there is some way in which we can send information backward in time and have it interact with what's happening back there in time in such a way that the outcome is changed. Now that sounds totally paradoxical.
It seems to defy common sense.
Yeah, for example, I had a grandfather, and my grandfather met my grandmother, and they decided to have my mother. My mother as a child, that is, and my mother grew up, and then she decided to have me when she got married. So if my grandfather hadn't met my grandmother, then how would I have ever been or even come into being?
Right.
So in the time travel paradox, known as the grandfather paradox, the time traveler enters a time machine, goes back in time to the era of the grandfather, and says to her grandpa, who doesn't recognize her, of course, don't marry that woman, meaning my grandmother. And he's wondering why, but then he thinks he has a connection to this strange traveler that just came into his being, and he decides that not to marry her. Their dinner together is disastrous. They don't get married. My grandfather never, her grandfather never marries, in fact, and lives an old age and finally dies. But yet, she's disrupted what's happened. How could this be? How could you keep your grandfather from having a mother and you if you prevented your grandfather from
because you wouldn't exist in the first place.
Exactly. So this is called the grandfather paradox. And the way out of it is called parallel universes. And the whole idea is that indeed, when you go back and tell your grandfather don't marry your grandmother, as you might do, and he doesn't, when you come back to the world in which you no longer exist, it's not the same world in which you left. You're now in a parallel world in which indeed your grandfather never married. So you can continue going backwards and forwards in time this way, and every time you enter a parallel world in which the outcome is you don't exist, because you're coming from a world in which you do exist. In other words, the world you left, the first world you left, your grandparents were alive. Your grandfather married your grandmother. But when you go into the next world or the next world or the next world, in all of those parallel worlds, there is no marriage between grandmother and grandfather.
Now, I know the parallel world or the multiple world theory satisfies certain problems in physics, and so physicists like it. However, I've got a problem with it, which is like, where are all those worlds? Like, we can't can't weigh them, we can't measure them, we have no place to put them.
Well, that's another interesting hypothesis which arises in the parallel worlds idea. I think it was Fred Hoyle who first came up with the notion that there's something basically wrong with quantum physics, because it basically predicts that at the outcome of every interaction, the participants which participated in the interaction enter into parallel possibilities, because quantum physics doesn't predict exactly what will happen in an interaction.
Yeah.
And so he wondered, how could anything be this way, the way it is now, with all these parallel realities?
Yeah.
So he felt that the way out of this is that there had to be some kind of time looping effect, some kind of time travel involved, but not necessarily the time travel of matter, of material substance, but time travel of information. So the information coming from the future is actually interacting with what happened in the outcome of the interaction in between whatever is interacting, and that future interaction, which has the greatest probability of occurring, is the one which we actually experience. So in other words, the experience we're having right now has not been predetermined by what happened in the past. It's being determined by not only what's happened in the past, but by what's also occurring in the future, as if the future was also present as much as the past has been present.
In other words, each and every one of us is receiving information not only from the actual future, but maybe from multiple different potential futures.
Exactly. And the fact that we're getting these multiple futures coming into us means that there is something of an option involved in which one we tend to go to, more or less. It's as if there is some choosing mechanism which arises through this parallel worlds time looping effect, which allows us to sometimes pick futures which are not necessarily the most probable. Sometimes we can predict. I mean, let's take the example of the baseball player. Pitchers are wonderful these days. They throw balls in all kinds of different ways. They have sliders, they have curveballs, they they have fastballs that can travel 100 miles per hour. They have change-ups in which you throw the ball in such a way that it only goes 89 miles an hour instead of 100. And batters, in order to bat, if you actually time how long it takes for a batter to get into position to hit a ball, it turns out that there's not enough time to make the decision when you do make the decision, which is when the ball's about 3/4 of the way to you from that. You have to make a decision not based upon what you see, but on what you intuit.
The ball is traveling so fast that the nervous system doesn't have adequate time to react.
You cannot determine by looking at the ball what's going on. You have to intuit. Now, the intuition of a good baseball player is 300 out of 1,000, he will hit it, which is amazing. In fact, most of the professional baseball players that hit with any degree of hittiness are batting within the range of 200 to 300, and anytime you're over 200, your intuition is working pretty well. I'm claiming to you that that's information from the future, and that these guys are seeing themselves hitting the ball at a certain position, which the ball coming into you is not telling you where that's going to be. You can't tell from the position of the ball when you make a decision that it's going to drop, it's going to go forward. You can't tell.
In other words, every single baseball game is actually a big parapsychology laboratory.
It's not only, well, yeah, I would say that, or a quantum physical parapsychology laboratory.
And you also have the influence of the fans as well. But now we're getting a little sidetracked.
Well, that's a different that opens up another door in which you might ask, well, what is the influence of a group psychology on the batter? But you see, these guys, when they're batting as well as they're batting, it doesn't matter which ball field they're playing at. It doesn't matter whether they're whether they're playing at home or they're playing at the their visitors. They're playing on the away team or on the away ballpark. So when you're playing away, usually you don't have fans following you
except
that can
on
influence
television.
you. What?
On television.
Well, people watching on television, sure.
Yeah.
So you might say, well, maybe they're feeling that. These all may be true. I can't say yes or no about them, but what I can say...
We're talking precognition, and I'm thinking psychokinesis.
Yes, I know. We had this discussion once before.
Yes.
And it may very well be that it is one rather than the other. But in my mind, it seems to be more that the person himself has the ability to transcend what would be a purely probabilistic attitude towards which way to swing at the ball, which would not be as successful as one in which there's an actual intent to hit the ball because one sees it coming at a certain position. So that's the one that seems more, let's say, comfortable to me. I'm not saying that the other ways, that it's the mass crowds, the television audiences, and all of that is somehow telling the batter, swing lower, even though it looks like it's higher. I mean, you know, or move or controlling the bat so it goes lower.
Well, it's clearly not a logical process in any case.
No, it is logical, but it's logical in a quantum physical manner. It's not logical in classical reality.
It happens so fast you don't have time to think about it.
You don't have time to think about it in the sense of normal thought processes. But let's even get into that for a moment, because in my point of view, thinking itself involves information from the future as well as information from the past. And in fact, in the model that I've been working on, which is occupying a lot of my time right now, is that thinking has a kind of tachyonic function, which means it involves something moving faster than light. And this is when things go faster than light, you have different ways in which one can interpret which way time is flowing. When things are slower than light, it doesn't matter how you interpret it. Everything happens in such a way that the before and the after are always completely distinguished, regardless of how you look at them.
That's known as tardionic.
Yeah, those are the tardionic elements. The tardionic elements always have a unique past and a unique future, but how far in the future or how far in the past those events are separated depends on one's point of view, according to relativity. But tachyonic is very different. Tachyonic, there is no unique past and unique future. What can be past and future for one observer could be just the reverse for the other. So the point I'm making about the tachyonic element of this is that when there is this aspect to it, you're getting information which is continuing to come into you in such a way that as you are producing the sentence that you're producing, more events from your past are coming in later and later and later in such a way as to give you a way of distinguishing what the next word is going to be.
So even in a conversation like this,
even in this conversation,
right now we're processing future information, potentially. Well, how does physics view tachyons? I know it's a theory, but is it accepted?
Oh, it's been one of the, let's call it, bugaboos of modern physics. But the funny thing about it all is that physicists totally believe in the so-called Higgs particle or Higgs boson the mechanism of the Higgs field to generate the masses of all of the particles in the universe.
Okay.
And
which is why it's sometimes referred to as the God particle.
There's the God particle. And the aspect of this Higgs thing is that the Higgs, in all of quantum field theory, in fact, any particle is really an excitation of a field. You might think of it that the field is like a wavy ocean, and the bubbles that pop up are the particles which come out, and each form of wave produces a unique form of bubble, let's say. So that's the way we think about this. Anyway, the Higgs field, when you look at the mathematical structure of it, it actually resembles a Mexican hat. In terms of where it's stable and where it becomes unstable.
Okay.
And it turns out that at the very top of the Mexican hat, it's like being at the top of a mountain, it's easy to fall off. When you're down in the brim part, it's easy to stay in that part.
Okay.
So the Higgs field has been pictured as a tachyonic field which slides from the unstable part into the brim part, and when it's in the brim part, it stabilizes. So everybody thinks, well, the initial universe was up there, tachyonic, because the Higgs field had to be created that way, but then it slid from that vacuum field into the vacuum field we now have. So that's how physicists think. They don't want to deal with the tachyon itself, which is still up there. But I think it's still up there.
Yeah.
And I think that there is tachyonic fields, and that particles themselves are capable of not only going forward in time, but they're also capable of going sideways in time. And it's a sideways in time action that is not moving forward in time or backwards in time.
I see.
Tachyonically, they're
I mean, moving across space.
Moving across space
in no time at all.
With no time at all. And that's the element of a tachyonic motion.
Yeah.
Now,
instantaneous.
Yes. You see, in space-time, we have no problem with the idea of moving forward through time and not moving through space at all. Tachyons are just the opposite, moving forward or backward through space, but not moving anywhere in time. Speed of light, you're not moving forward in space, you're not moving forward in time. That's the splitting point. So tachyonic fields are all spatial, no temporal. Temporal fields are all temporal, no spatial. And the light field is one which is no space, no time.
Well, a lot of physicists might say something like, Fred, this is all well and good. However, it only applies to the most infinitesimally small subatomic particles, and it's irrelevant for us in our Newtonian macro world.
It is a very good argument to make that argument. The only problem with it is that everything is ultimately dependent on what's happening in the micro world. The world of everyday experience is built up from that.
Yeah.
And the question is how much of that primary or fundamental world is something that we experience in this world. Recently, not too long ago, Sir Roger Penrose and Stuart Hameroff had postulated a wonderful theory in which they said it was the microgravity which is causing the wave functions to collapse, meaning it's the microgravity or the gravity acting on that very fine, very small scale that is actually creating the way the universe of consciousness and matter appears.
How do you evaluate that?
Well, I have nothing but admiration for Sir Roger Penrose. This guy's a brilliant mathematical physicist, and Stuart is also a very intelligent guy. I mean, he's for an anesthesiologist, he knows a hell of a lot of good physics, and he impresses me.
Well, I mention it because I think our viewers now might be interested in knowing I did a 6-part interview with Stuart Hameroff on this theory, so they can check the listings for that, and I'm glad to know it ties into your thinking.
Absolutely, absolutely. There's an intuitive element that Penrose certainly has, which has greatly influenced Stuart Hameroff, and to produce this rather remarkable theory of consciousness that they have. I'm not sure I agree at every detail of what they've come up with, because I don't understand every detail of what they've come up with very well.
And there are probably many variations of the theory that different people have contributed, such as our mutual friend Jack Sarfati has his own variation of it, I know.
That's right. But the most important thing to me is that this Higgs field is something which has a tachyonic element. Its elementary form is tachyonic, since it produces a particle called the Higgs boson, which is responsible for giving mass to particles moving forward through time. It's also responsible for producing imaginary mass, which is giving particles trajectories going nowhere in time but forward or backward in space. And this is a concept which is involved, which can be found in the equations if you play with them enough.
Well, in the equations, but is there any possibility of actually measuring a tachyon?
It has been thought that a measurement of such a particle, a tachyonic particle, could be made, and people have been looking for it. But so far, nobody's found anything like a tachyon. So the tendency is to believe that it's not a material particle. But I would start right from the very beginning by saying I don't expect it to be a material particle. It's something which has kind of it has an imaginary mass, and because it has an imaginary mass, you're not going to find it unless you are willing to explore at speeds greater than the speed of light. So you got to be in the world of speeds greater than the speed of light. You'd see tachyons all over the place.
But now you're talking about
matter would seem really weird.
Imaginary mass. That's a very interesting concept. It reminds me of what are sometimes called virtual particles.
They're not quite the same. A virtual particle is something which occurs in an interaction when there's an exchange. And the exchange then has initial particles coming in, final particles coming out of the exchange area, and the virtuality of that involves some exchange between a particle which appears from in one place and it disappears in another place, between the places where the particles are interacting. It's the messenger which carries the interaction, and so you never see it. All you see is the final and the initial. So
it's different than an imaginary.
Oh, definitely. Imaginary particles appear as a consequence of being faster than light. This all comes about through Einstein's theory of relativity, and
which says that nothing can go faster than light.
Actually, it doesn't. That's what's interesting. It doesn't really say that. In fact, you can perfectly allow tachyonic particles in the theory of relativity. They're paradoxical because, as I said, they have imaginary mass, which seems very strange. They can never slow down slower than the speed of light. At the speed of light, they have almost infinite. They have infinite energy. As they approach infinite speeds, they have no energy. So this is totally opposite of the way our massive particles at zero speed have no energy, but as you approach the speed of light, they have infinite energy. So just the reverse for tachyons. They have infinite energy at the speed of light, but as you speed up, no energy. So that's why the tachyonic fields are very appealing to me, because there's not an energetic, it's not energy that's making thought. It's the tachyonic fields themselves that are the source of thought. And in my book, Time Loops and Space Twists, I devote a whole chapter as to why that occurs and how it occurs. And it involves something called the Doppler effect, which is well known to people, but you can look it up and see how this applies when there's a tachyon involved. When there's an ordinary particle involved, the tachyonic behaves as a particle behaves a certain way, and we understand that. When there's a tachyon involved, things are different in terms of how the information being sent from the tachyon to another particle actually transpires. And that difference allows the past to start, as you move forward with your thought, the past starts bringing in information gradually to you so that you can construct sentences based upon memory. And sometimes when it's a complicated sentence that you're constructing, you have to go pretty deep into your memory level to find the correct construction to finish the sentence.
Sure. And at the same time, as you point out, we're dealing with information coming from the future.
Exactly. In fact, anybody can do this. If you're watching this at home, and just say something, make a sentence, say it out loud, and then when you're all done saying that sentence, ask yourself, how did you know what the last word of that sentence was going to be before you uttered the sentence? When you make a sentence, you don't know what the last word is going to be until you actually say the last word. And now, the last word was word. But when I started that sentence off, I didn't know it was going to be word until it could have been puka paka. I don't know what I'm going to say until I say it.
Right.
So the point is, yet you said it, and when you put it all together, with hindsight, it's a sentence which has
linguists would describe that as an act of intuition.
Exactly.
Yeah.
Exactly. That's exactly what this, in a sense, the tachyonic field has something to do with. It has to do information coming from the future, or if you will, tachyonic, which
that's how you define intuition, is an appreciation of the future.
It's an awareness of the future coming back to you.
Okay.
It's the awareness which keeps you from being pounced on in ancient times by the bear outside the cave. As I say, those of us in humanity that got pounced on, they're not around anymore.
Well, Fred, we've covered a lot of ground here. We've got less than a minute left. Is there a final word or thought you'd like to leave with our viewers?
Well, what I would say is that people should encourage themselves to think about their lives in a completely holistic manner, which means not only the material needs that they have in the present moment through their senses, but also to be aware that you will all get information from the future. It's your natural inheritance of being a human being, and that abilities or thoughts may occur to you that you never thought were possible, that you have wanted to do and maybe you were afraid to do, and suddenly you realize, maybe with the understanding that this is not nonsense, it's real, it's quantum physics, that you can actually do these things.
The future is beckoning each and every one of us.
Exactly. The future calls.
Fred Alan Wolf, thank you so much for being with me for this 3-part series.
You're very welcome, Jeffrey. Thank you.
And thank you for being with us.